Question 6. Methanol can be manufactured and a reversible reaction as shown. Figure 3 shows how the partial pressure changes time at constant temperature. Draw cross X on appropriate axes of figure 3 when the mixture reaches equilibrium. When it's going to reach equilibrium, it's going to be somewhere around here, right? However, you don't put the X here, which is a mistake I made, on the appropriate axis. So you put the X here. So if you remove all, the X would just be here. X must be on or just below line of X-axis. Yeah, that's just below or on. You can't put X here. Don't do that. X is just below here. Curly X. Then it says a 0.23 mole of carbon monoxide is mixed with hydrogen, 1:2 mole ratio, allowed to reach equilibrium. Equilibrium mixture contains this much of carbon monoxide. Total pressure of this is that. Calculate partial pressure. Then Kp, then that, and then that's it. So this is the really hard question out of these, since it's mathematical, it's 4 marks. So we have the moles of we know that equilibrium moles of hydrogen equals 0.24, because we know it's a 1:2 mole ratio. If you've got this many moles of carbon monoxide at equilibrium, times by 2 will get the moles of hydrogen at equilibrium. So now we've got that. How do we, well, now we can find the total number of moles, we can find a mole fraction. Okay, let's do that. So the total number of moles, equilibrium obviously is going to be a total number of moles is going to be 0.230 plus it's going to be 0.047 not equilibrium moles. The moles is going to be 0.47 total. Now you can find out the mole fraction of hydrogen. Because we're just trying to find a partial pressure. Oh yeah, we're just trying to find partial pressure of hydrogen. So mole fraction is going to be 0.24 over 0.47. .51, and therefore to find the partial pressure with 0.24 over 0.47 times by the total pressure 1.04 times by 10 to the power 4 1.04 times by 10 to the power of 4, and we'll get 5,310 kilopascals rounded. So that's 6.1, 6.2. 6.3, given an expression for the equilibrium constant Kp for this reaction. Kp is going to equal, remember curly brackets, it's going to be CH3OH so partial pressure CH3OH over H2 squared, or actually over CO times by H2 squared. Partial pressure, curly brackets, not allowing square brackets, that's Kc, curly brackets, CH3OH over H2 squared times by carbon monoxide. And the units, well, we know it's in kilopascals, so it's going to be kPa over kPa times by kPa squared, kPa cubed, which is the same as 1 over kPa squared, which is kPa to the power minus 2. Because remember, that cancels, you're left with 1 over kPa squared. Some more carbon monoxide is added to 6.4. Some more carbon monoxide is added to the mixture in question 6.2. The new mixture is allowed to reach equilibrium at temperature T. State the effect, if any, on the partial pressures of methanol and on the value of Kp. Well, if you're adding more carbon monoxide, well, the effect on partial pressure of methanol, if we add more carbon monoxide, well, it's going to increase then. Because remember, partial pressure is just mole fraction. I'm pretty sure it's this. It's mole fraction, yeah, times by total pressure. And that is partial pressure. So if you think about it, we're increasing mole fraction. This is getting bigger, so we're doing a bigger number times the same number. So it's like 5 times by 2 equals 10. The 2 stays the same, but we're going to increase the 5 to a 6. But we get 12, which is a bigger number. And that is the partial pressure. So the partial pressure will increase when we add more carbon monoxide. The effect on value of Kp, no effect. State the effect of any of the addition of a catalyst on value of Kp. Again, catalyst won't affect the value of Kp. And that's a bit cheeky. Both of these answers are Kp, so students might be like, oh wait, that can't be right, and then probably change it, but they were actually right in the beginning. No effect, no effect. And why? And explain the answer. Increases as catalysts increase the rate of forward reaction and reverse reaction equally, or catalysts do not affect the position of equilibrium. Catalysts do not affect the position of equilibrium. And that is the end of question 6.